Hi everyone. Today we're going to study z-test for mean. Let us first discuss the 5 steps for solving hypothesis testing problems. And this is what we call the traditional method. Step 1 is state the hypothesis and identify the claim. Step 2, find the critical value. Step 3, compute the test value. Step 4, make the decision to reject or not reject the null hypothesis. Step 5, summarize the result. Now let us define z-test. The z-test is a statistical test for the mean of a population. It is used to test the hypothesis when n is greater than or equal to 30. This n is the sample size, or when the population is normally distributed. And sigma is known. Sigma is the population standard deviation. The test statistic Z is defined as, the formula is Z equals x bar minus mu all over sigma divided by the square root of n. X bar is the sample mean, mu is the population mean, sigma is the population standard deviation, where n is the sample size. When n is greater than or equal to 30 and sigma is not known, sample standard deviation S can be used. So the formula will be like this: Z equals x bar minus mu all over S divided by the square root of n. Let us see this example 1. A researcher wishes to test the claim that the mean number of days that a basic model automobile sits on a dealer's lot is greater than 29 days. A sample of 30 automobile dealers has a mean of 30.1 days for basic model automobiles. The standard deviation of the population is 3.8 days. At alpha equals 0.05, is there any evidence to reject the claim? We note that since n is greater than or equal to 30, this is the sample size, and sigma is known, the z-test can be used. So step 1, we state the hypothesis and identify the claim. So we write here H sub 0, this is the null hypothesis, colon, mu equals 29. This 29 is the number of days here. And H sub 1 is the alternative hypothesis. The word greater here denotes a greater than symbol. So we write mu is greater than 29. And this alternative hypothesis is the claim in this problem. Step 2, find the critical value. Since alpha equals 0.05 and the test is a right-tailed test, the critical value is z equals positive 1.65. We get this value from the normal distribution table. To illustrate, the alpha is the 0.05, that is the area of the critical region. This critical value is the 1.65. And this critical value separates the critical region from the non-critical region. Step 3 is to compute the test value. Our formula is here, z equals x bar minus mu all over sigma divided by the square root of n. Substituting the corresponding values, we have now 30.1 for the x bar, minus 29, that is the mu, all over sigma is the 3.8, divided by the square root of n, and our n is 30. Simplifying further, the numerator is now 1.1 and the denominator is 0.69378. Getting the quotient, we have 1.59. We take note that this 1.59 is less than 1.65, so this is on the left side of 1.65. And for step 4, we will make the decision. Since the test value positive 1.59 is outside the critical region, the decision is not to reject the null hypothesis. Or we say we accept the null hypothesis. So for step 5, summarize the results and we will write, there is not enough evidence to support the claim that the mean time is greater than 29 days. By the way, when we say accept the null hypothesis, it also follows that we are rejecting the alternative hypothesis. This is our final answer. Let us see example 2. A medical rehabilitation education foundation reports that the average cost of rehabilitation for stroke victims is $24,672. To see if the average cost of rehabilitation is different at a particular hospital, a researcher selected a random sample of 35 stroke victims at the hospital and found that the average cost of their rehabilitation is $26,343. The standard deviation of the population is $3,521. At alpha equals 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from $24,672? First, let us note that since n equals 35 and sigma equals 3,521 and is known, the z-test can be used. Step 1 is we state the hypothesis and identify the claim. we write here H sub 0, that is the null hypothesis, and we write mu equals $24,672. While H sub 1, the alternative hypothesis, we write mu is not equal to 24,672. The word here is different. It can be more than or less than. So it denotes a not equal sign. And this alternative hypothesis is the claim in this problem. For step 2, we find the critical value. Since alpha equals 0.01 and it's a two-tailed test, for alpha divided by 2 equals 0.005, the critical values are z equals plus or minus 2.58. We got this value from the standard normal distribution table. For step 3, we compute the test value. The formula is here, and let us do the substitution. X bar is 26,343 minus the mu, which is 24,672, all over sigma is 3,521 divided by the square root of n, where n is 35. Simplifying further, the numerator is now 1,671, while the denominator equals 549.5193. Getting the quotient here, the value is 3.04. Step 4 is to make the decision. We will reject the null hypothesis, since the test value falls in the critical region. It means to say also that the test value is greater than the critical value. With our figure here, the critical value is placed in between the critical region and the non-critical region. So this is 2.58, that is the positive one, and the negative is in here. The two tails are shaded, and these are the critical regions. And this area in yellow is the non-critical region. The test value is 3.04, and we write it on the right side of the critical value. And this falls in the critical region. So for step 5, we summarize the result, and we say that there is enough evidence to support the claim that the average cost of rehabilitation at the particular hospital is different from $24,672. By the way, when we reject the null hypothesis, we are accepting the alternative hypothesis. This is the final answer. I hope you learned something from this video. See you again next time.